Hello folks, and welcome to the last video for linear inequalities. Before we get into today's video, I do quickly want to talk about the difference between positive and negative. And this is something that I'm not sure everyone has a full grasp of. So let's just talk about it real quick, and then hopefully this will help us understand what happens in these types of questions we'll be talking about. So here I have an example. So we have our number line here, and we're being asked, how does the position of a number on a number line determine whether it's greater or less than? So we know this from graphing inequalities, that when you have a number that's further to the right, it gets greater, and when you have a number that's further to the left, it gets less than. Well, the same thing is true for negative numbers, right, and positive numbers. We know that when we're talking about zero, numbers that are to the right of zero are positive numbers, and numbers that are to the left of zero are negative numbers. But they're the same numbers, right? So you'll notice that on either side of zero, we have a 1, right? We have a positive 1 and a negative 1. And then the next number would be a 2 and a negative 2. And the next number is a 3 and a negative 3. So positives and negatives mean the same thing. So a positive 3 and a negative 3, they both mean that I am 3 units away from 0. The only difference is what direction am I moving, right? So a negative 3 says I'm going to be 3 units to the left of 0, and a positive 3 says I'm going to be 3 units to the right of 0. And those of you that are taking or will take a science course that talks about these types of things, we call these scalar versus vector quantities, meaning that if something has a vector, it has a direction. So for example, if I wanted to look at an object's velocity, if you take like physics, you'll talk about its velocity being positive or negative depending on the direction it's moving. But when we're talking about a scalar quantity, we're just talking about its overall distance. I don't care what direction we're talking about. So that could be something like speed. We don't talk about negative speed because it doesn't talk about direction. And I know speed and velocity, some of you might think are interchangeable, but that's the distinction between the two, is speed can't be negative. Speed is always positive because it's talking about this, what we call a scalar value. Well, negatives on our number line, that's just talking about it's a direction, it's a vector. So when we're thinking about this, we have to consider also this idea that right means positive, but right also kind of means greater than, and left means negative, but left also kind of means less than. So when I'm looking at this question here, how does this explain why 2 is less than 3? Well, what are their position, right? Because 2 is to the left of 3, it's going to be less than 3, right? But then what happens is when I make both of these symbols or both of these numbers negative, so instead of a positive 2 and a positive 3, I have a negative 2 and a negative 3, what ends up happening is my symbol has to reverse because negative 2 is no longer to the left of negative 3, it's now to the right of negative 3. So this is the big difference when we were talking about the last video when we were just adding and subtracting to solve these equations. Now that we're multiplying and dividing, what's going to happen is if I multiply or divide by a negative number, I have to change my symbol to make sure that I'm going in the right direction. So consider this for a second. So negative 1 is less than 2. I think we're all okay with that. We should all understand that idea. And again, why is that? Well, negative 1 is to the left of 2 on the number line. And if I took that and I multiplied it by 3, well, multiplying negative 1 by 3 simply just makes it more negative. It brings it further to the left, and multiplying 2 by 3 just brings it further to the right. So obviously my inequality symbol is not going to change, right? And the same thing if I wanted to divide them by 3. So negative 1 divided by 3 is negative 1/3, and 2 divided by 3 is 2/3. Again, it does bring them closer together, but they're still on the same side of 0 that they were previously, right? My negative 1/3 is still to the left of 0, and my positive 2/3 is still to the right of 0. But what if, instead of multiplying and dividing by negative 3, I took them and I multiplied them and divided them by negative 3? So what happens is, well, the negative 1, when it gets multiplied by negative 3, it goes to the other side of the 0, right? Instead of being to the left of 0, it ends up bringing it over to the right of the 0. And the 2, when I multiply it by negative 3, ends up bringing that over to the left of 0. So what ends up happening is they switch sides, right? They switch what side of 0 they're on, which means that these symbols, these inequality symbols, have to switch as well. And then the same thing is going to be true for dividing by negative 3. Again, negative 1 divided by negative 3 turns it into positive 1/3, and that is on the right of 0, right? And then 2 divided by negative 3 turns it into negative 2/3, and that is on the left of 0. So again, because they are switching the sides of 0 that they are on, my inequality symbol also has to change. Okay, So these examples, they illustrate these two properties right here. When each side of an inequality is multiplied or divided by the same positive number, the result of our inequality will be the same. It's still going to be whatever it was. So if it was a greater than, it's going to remain greater than. If it was a less than, it'll stay as a less than. But when the inequality is multiplied on both sides by or divided by a negative number, that's when we have to change the symbol, because that's going to change the side of 0 that that number is on. So what does that look like? Well, here we go. So I have negative 5s less than or equal to 25. So what does that become? Well, if I want to solve for s, what do I have to do? I have to take both sides of my inequality and I have to divide it by negative 5. So negative 5 divided by negative 5 turns my negative 5s simply into an s. And then 25 divided by negative 5 turns that into negative 5. But then what happens is, because I divided by a negative, my less than symbol has to turn into a greater than or equals to symbol. Part B here, we have to divide this side by 7 and divide this side by 7. So 7 divided by 7 leaves me with a, and negative 21 divided by 7 leaves me with negative 3. And you might be thinking to yourself, well, I have a negative there. Does that mean I have to flip the symbol? And the answer is no, because I didn't divide by the negative, right? Whatever I'm dividing by will tell me whether I flip the symbol or not. So because I divided by positive 7, my less than symbol, well, that's simply just going to stay as a less than. Same thing here. I want to get this y by itself, so I have to undo dividing something by negative 4, and to do that, I'm going to multiply by negative 4, and whatever I do to one side, I have to do the same thing to the other side, so I multiply by negative 4. Negative 4 is canceled, and it just leaves me with y. Negative 3 times negative 4 gives me positive 12, and again, because my greater than symbol we had to multiply by negative 4, it's going to turn it into a less than symbol. And then last one here, I want to get rid of k divided by 3. So we're going to times by 3 and times by 3. And we get k and we get negative 6. And because the 3 that I multiplied by was positive, my greater than or equal to symbol is going to stay as a greater than or equal to. So if you want to pause the video here, try to graph these, and then you can check your answer. That's probably not a bad idea to get a little practice. So I'll give you a second right now to pause it. All right, so then if you did pause it and you checked it, these are what your answers should look like. So we have s greater than or equal to negative 5. So that's my closed circle. And then we're greater than or equal to. So that's s. We'll color code these. A less than negative 3. So we have less than. So we should have an open circle. We have strictly less than, so an open circle. And then less than tells me I'm going to the left. We have y less than 12. So again, open circle, and we are going to the left. And then finally, we have k greater than or equal to negative 6. So we're going to close our circle, and we're going to go to the right. And there we go. So just like with linear equations, we might run into one of these ones where we have a multi-step inequality where it's not just simply dividing or adding. It may be a combination of all of them. And depending on the direction I move these things, I might have to flip my inequality, but I might not. So what I mean by that is I'm going to do this in two different ways, and you'll kind of see what happens. So strategy number one, what I'm going to do is I'm going to bring all of my a's to the left-hand side, and I'm going to bring all of my numbers to the other side. So I'm going to minus, so I got negative 2.6a plus 14.6 greater than negative 5.2 plus 1.8a. So I'm going to minus my 1.8a, and I'm going to do the same thing over here, minus 1.8a. And at the same time, I'm going to minus the 14.6, and I'll minus the 14.6 over here, right? So once we get more and more comfortable with these things, we can start doing multiple steps in one. So that's what I'm doing here. So 1.6, negative 2.6, sorry, minus 1.8 is negative 4.4a, and that's going to be greater than, and negative 5.2 minus 14.6 is negative 19.8. All right, grab our calculator because now we're going to have to divide, right? I want to get a by itself, so we're going to have to get rid of this multiplying by negative 4.4 by dividing by negative 4.4, and we'll do the same thing on the other side, dividing by negative 4.4. So we get 19.8 divided by 4.4, and we get 4.5. So we get a, and we get 4.5. Notice I didn't use the negatives in my calculator, but I recognize here that I have a negative divided by a negative, which turns it into a positive. And since I am dividing by a negative, we have to take our greater than symbol, and it now becomes a less than symbol. Perfect. Awesome. Now, I said that there's two ways that we can deal with this. If we don't want this negative 4.4 in front of my a, what I could have done instead is I could have taken my negative 2.6a and moved that instead of my 1.8. So what does that look like? So negative 2.6a plus 14.6 greater than negative 5.2 plus 1.8a. So I can plus my 2.6a and plus my 2.6a here, 2.6a, and then I can plus my 5.2 and plus my 5.2. So what I get is I get 19.8 greater than 4.4a, and what you'll notice is I end up with the same values. I end up with 4.4 and 19.8. The only difference here, instead of them both being negative, they're both positive. So now when I divide both sides by the 4.4, I don't have to flip the symbol. 4.4a, 4.4a, so I get 4.5 less than, oops, not greater than, less than a. But we always read it from the variable. So if I wanted to read this from the variable, really it turns into a, how did I flip it again? I don't know what I'm doing this morning. There we go. Greater than, so it turns into a less than 4.5. Perfect. So what we see is that no matter which way we did it, I get a less than 4.5 on both sides. Perfect. So then it's asked me to verify my solution. So again, how do I verify? Well, I take a number that now satisfies this new inequality and I plug it back into my original equation. So I'm going to plug it back into my negative 2.6a plus 14.6 minus 5.2 plus 1.8a. So if we wanted to pick a number that's less than 4.5, let's pick 4 and see what happens. So I get negative 2.6 times 4 plus 14.6 greater than negative 5.2 plus 1.8 times 4. Okay, so negative 2.6 times 4 is negative 10.4 plus 14.6, and that needs to be greater than 5.2 plus 1.8 times 4 is 7.2. So we get what? 3.8. No, 4.2, and that is greater than 2. And does that work? Yeah, sure does, right? 4.2 is in fact greater than 2. So we're pretty confident about our answer now because we verified it, right? All right, so one last thing, let's talk about another application problem, because this is kind of the end goal for a lot of these topics, is how do I now use these things to help me solve some kind of situation. So a super slide charges $1.25 to rent a mat and $0.75 or 75 cents per ride. Haru has $10.25. How many rides can Haru go on? So step one, choose a variable, right? So like, let's let a variable, so let R be the number of rides, right? So generally we want to establish some variable because that's the thing I'm going to solve for. So in this case, I'm saying R and it's standing in the place of rides. So how do I calculate the price that Haru spends? Well, he has to initially put up his $1.25. So he has to spend $1.25 plus, and then it's 75 cents per ride. So 0.75 times R. And this thing has to be less than or equal to, because that's how much money he has to spend. So we don't necessarily have to spend $10.25. We can, but we just have to make sure that we spend that much or less. So maybe there's some kind of concession stand. So he wants to save some money. So he doesn't want to spend all $10.25. Maybe he just wants to spend $8 and have a little bit left over. Or maybe he does want to spend the entire amount of money. I don't know, but like this is why we'd use an inequality in this case. So part B then says to solve this thing. So how do we solve? We take our inequality and we get the R by itself by getting rid of the other operations. So the first one I have to get rid of is the 1.25. So we're going to minus 1.25 from both sides. And I get 0.75 R less than or equal to 9. And notice I didn't do the divide and the minus at the same time, whereas in the last question, I did do two operations at the same time. The reason I was able to do two for this one was because they were both subtractions. In this case, because I have one subtraction and one multiplication, I have to take my time and do them one step at a time. All right, so we have 9 divided by 0.75, right? So we're going to divide by 0.75 on both sides to get the r by itself. And we get that r is less than or equal to 12. So that means Haru could take no more than 12 rides. He could take less than 12. He could take up to 12, but he couldn't take 13 or 14 or 15, right? Lastly, it says to then graph our solution. So if Haru was a very industrious child and wanted to go to his parents with this information, he might then show them a graph to say, this is how many rides I could take, right? So here we go. We got 10 rides, 11 rides, 12 rides, 13 rides, 9, 8, and so on. So what does this look like? Again, we're not going to graph our original inequality. We're going to graph the reduced one. So less than or equal to means I am using a closed circle at 12, and I'm going to the left from there. All right, so that is it for linear inequalities. I will see you all in the next video.